Alright, welcome back to geometry. Angle pair relationships, section 1.6 is what we're going to talk about next. And I'm introducing a new thing to you. Alright, so if we were in a classroom, I would ask you questions. And then you would look at, your mind would go blank, and you would look at me blankly, and I would give you hints by giving you hand signals to help you remember. But not only are the hand signals good for this, the hand signals are hooks to put the really important stuff into your memory. So we're going to learn our first hand signal today. And I want you to do it even if this is you're just taking it virtually and you are not going to be in a classroom with me looking at you, trying to get you to remember and going. Okay, so we're going to learn some hand signals. We already know some songs. We know the substitute song. And we're going to have some hand claps and some dances. So just embrace it. All of this is not just pure silliness. This is going to push it into your long-term memory. I had a girl who, she took geometry like 4 years before from me. And she was taking the SAT and suddenly she remembered one of my many hand signals and she was like, getting all of these right, because the hand signal was helping her pull that back up when she needed it when she got to the SAT. Alright, so play along. I promise it'll have a payoff. Okay, and just think you're at home. Nobody even can see you looking silly. So do it. Alright, so here's our thing. If we have two lines, I'm going to go with black here, that cross. And these have to be straight lines. We're pretending mine are. Like with a ruler, then we can number our angles here that are made by the straight lines. I'm going to do mine the same as theirs. And they labeled these 4 angles 1, 2, 3, 4. Okay? Now, they have a name for the angles that are across from each other. So 1 is directly across from 3, and 4 is directly across from 2, and I'm making them the same color so you can see that. Alright? So these angles that are directly across from each other, they don't call them directly across because, no, that'd be too simple. In math, we always have to, in science, we always make fancy words so we sound smart. So these ones that are straight across from each other are called vertical angles. Now you can see why 1 and 3 are called vertical angles, but it really doesn't work with 4 and 2, but they're still called vertical angles. And this is what I want you to do. Everybody get out your 2 straight things that God gave you here to learn geometry with, your fingers, and make them into an X. Now, do like me and do this with the X. Do you see, as I do this, that the ones across from each other are always the same? When I go like this, 1 and 3 get smaller, and when I go like that, 1 and 3 together get bigger. And the same thing is happening with 4 and 2. So this is our first little thing we've learned, is that vertical angles are congruent. Notice how I did 1 line on both 1 and 3 and 2 lines on both 4 and 2. They are always equal to each other. Vertical angles are congruent, fancy math for the same measurement. Alright? So this is going to be really important. We're going to need to remember vertical angles for the whole rest of this class, because we are later going to prove things that, like, triangles are the same, and we're going to have a reason to prove it, just like that proof I showed you. And one of the ways that you can prove something to be the same is vertical angles. Alright? First hand signal. And wait, there's more. I don't know if you learned today or not. Alright, the other thing is the idea of linear pair. So I'm going to erase this, and, well, no, I should have kept that one. Leave that. Okay. Oh, that's pretty pitiful, but you can pretend that was a straight line. Alright, so now we have 1 and 4, and 1 plus 4 is a straight line. So these are called a linear pair. A linear pair. Okay? So if you can add them up and they make a straight line, do you remember what I told you a straight line equals? That's right. 180 degrees, then it's a linear pair. Alright, that's what we are learning. And now you have to identify some vertical angles, some angles, looking at page 44. and whether or not things make a linear pair. Now, one of the things in the book is if things look like they make a line, they do make a line. They don't try to be tricky with that. All right? Now look on page 45. Let's do this little example too. In the stair railing shown at right, angle 6 has a measure of 130. Find the measure of the other 3 angles. Okay? So I'm going to draw this up here. So we have 2 lines crossing, making vertical angles. And our numbers here are 5, 6, 7, 8. And they tell us that angle 6 equals 130 degrees. All right? So now, how do we get all the rest? Well, linear pair, we know that angle 8 is also 130 degrees. How do we get 5? 5 and 6, did I say linear pair or vertical angles? Vertical angles, those are the same. These two are a linear pair, so we know that 5 plus 6 equals 180, and this is angle 5 and angle 6, because 5 plus 6 does not equal 180. All right? So we're going to say 5 is our unknown, so we're going to make that x, and 6 is 130, which together is 180. Now, do you remember how to solve from x for algebra? You do it by doing the opposite. And what you do to one side, you do to the other. So x has 130 added to it. It's why x is not alone. So we're going to do the opposite and subtract 130. And what I do to one side, I have to do to the other. 130 minus 130 is 0, but I don't write it down because that's just confusing. X wouldn't be alone anymore, and I want x alone. 180 minus 130 is 50. So x is 50 degrees, so 5 is 50, and 7 would be also equal to 50 because of vertical angles. All right. Okay. How much time do I have? 4 minutes. Okay. I want to do that one, but I want to teach you page 46 first, and if I have time, I'll come back. Okay, look on page 46. If you have 2 angles that add up to be 90 degrees, they're said to be, so if they add up to be 90 degrees, they're said to be complementary. Complementary. If you have 2 angles that add up to be 180 degrees, they're said to be supplementary. And how you can remember that is, watch this, my complementary, I can turn into 90, and my supplementary, da-da, can be 180. So complementary has C in the 90, and supplementary has the S for supplementary in the 180. Complementary and supplementary. You see those terms in your book on the top of page 46. If angles are next to each other, they're said to be adjacent. We're going to use the word adjacent a lot in this class. If things are not next to each other, they are non-adjacent. Okay. Okay, we have enough time. I can go back and do number 45 for you before I run out of my 12-minute limit that this thing seems to have. This is definitely keeping me from wandering off on as many rabbit trails as I usually do. Keeping me focused, it's a good thing. All right, look at example 3 in your book. Let's see if I can draw it the way theirs goes. Okay, one line goes this way. One line kind of goes that way. We got A and B, and these are lines that continue, and C and D. Okay, this one is y plus 20. This one is 4y minus 15. This one is x plus 15. And this one is 3x plus 5. All right, So they want us to solve for x and y. If this had been an x and that one an x, we could have set these equal and solved for x. But this one has x and this one has y, and no one wants that. No one wants to bother with an x and a y. We want one set of formulas with x's and one with y's. So what we're going to do instead is we know this angle plus this angle makes a straight line, so they're supplementary. So we can say y plus 20 plus 4y minus, that's a terrible 4y minus 15 equals 180, because they're a straight line. Now, this is our first dance. We're going to gather up or get together everything that's a y. And this is how the dance goes. And it has a song. Gathering up your terms, twice on each side, stowing away the time. Gathering up your terms. Okay, got it? 2 on each side. Now, if you're taking the SAT, just sing in your heart, not out loud. Don't get kicked out. All right, so 1y plus 4y, there's an understood 1 there, is 5y. 20 minus 15 is 5 equals 180. Now, why is y not alone? We work from the outside in. The opposite of minus 5 is plus 5. What I do to one side, I do to the other. So I get 5, I bring down what I didn't mess with. 5y equals 185. Why is y not alone? It's being added to a 5. It's being multiplied by a 5. A number sitting next to a letter is multiplication. The opposite of multiplication is division. What you do to one side, you do to the other. These cancel out, and 185 divided by 5 is?
37.
37. Thank you. Okay, so y is 37, put a box around it. Alright, so here's our x's added together. We're going to gather up our terms, gathering up our terms. There's the dance. Okay, 3x plus 1x, understood 1, is 4x plus 5 plus 15 is 20 equals 180. The opposite of plus 20 is minus 20. What I do to one side, I do to the other. 4x equals 160. X is being multiplied by 4, so I do the opposite. I divide by 4. Those cancel out. X equals 40. Ta-da! Math is fun.